In this video, we're going to look at right triangle trigonometry. And so let me dive right into an example of where we will be eventually going, but we aren't going to get to this example in today's video. We're going to set the foundation for that. So here's the question. Find the value of x in the triangle below. And I see a triangle. I see that's a right triangle. And so you might think, okay, so maybe we can use the Pythagorean theorem, a squared plus b squared equals c squared. That's what we've been doing to solve for sides in a right triangle so far. And so we have a right triangle. We know that a and b have to be the legs. C is the hypotenuse. I can do similar things here and see that c would be 10. But here's where the problem comes in. I don't have a side length here. I have a side length there, so I have an x squared. But I don't know what this is. Now, the common mistake I see, and this is not correct, I see people, some of my students say, well, if I don't know what this is, then we make it x, like we've always done, and we get an x squared here. But this would mean these two sides are the same. I don't know these are the same. This is wrong. I cannot do that. Now, I could try to make this a different variable. I could try to make this, let's say, y. But the problem here is I would have x squared plus y squared equals 10 squared. And since I have an x and I have a y, I can't solve this equation and get a specific number, a determined number. If I solve for x, it'll have a y and stuff. Here's where the trick comes in, okay? You notice in this problem, we have another angle. We have a 40-degree angle. And without getting into too much detail, I know that this triangle is determined. I can find a specific value for x because of this 40-degree angle. The bigger this angle becomes, the longer this side becomes. I put a little x there, that's not going to solve this. The smaller this angle becomes, the smaller x will be. But this equation here does not include angles. So, setting up a few things. First of all, if I want to label some sides, so if I have a right triangle, let me draw that. And I'm going to put in an angle. Now, I could put a variable x. I'm going to use a different variable, a Greek letter. I'm going to put what's called a theta here. So let me just tell you what that is. So theta, which is, it's like an O with a little line through it. And it's just a Greek letter. And you can think of it, so you can think of this just like any other variable. Think of it like an x, so some unknown value. We often use Greek letters for angles. That's not important to the math we're doing here, but you will see oftentimes you'll see Greek letters creep in when we start doing trigonometry. So if you see this, don't freak out. Okay, now labeling these sides. So I have three sides. Now let me go over, and the first one I'll talk about is the hypotenuse. So this is the longest side. It is also the side that is opposite the right angle. And this second rule here is the one that I'm going to use to find the hypotenuse whenever I do it. Sometimes you can see this is the longest side, but sometimes the triangle might not clearly show that this is longer than the other sides. But if I start at the right angle and go opposite, opposite means across, so across from the right angle, this has to be the hypotenuse. Now the legs. The legs are the two shorter sides, the two sides that are adjacent to the right angle. The opposite leg is the side, and more specifically the leg, opposite or across from the given acute angle. Lots of words to say this. I have given you this angle here. If I go across, so I go straight across, and look over here, this is my opposite leg. Now, some students have trouble with that. I've seen way too often people go and mess up and go to the wrong side. So another shortcut is you can, if you want to find the side opposite this angle, you can take your hand. Now this clearly isn't my hand. It's clearly this sort of rectangle of doom. And if I were to cover up this angle, the side that's left is the opposite side. So that is something that you can do if you're having trouble doing the work with just going across. All right, adjacent leg. So let me go to a light blue. Adjacent leg is the leg adjacent, and adjacent means next to the given acute angle. And I can put these in any order. I usually like doing the hypotenuse first. Most students have no problem finding the hypotenuse. I like doing the opposite next because there's this nice way to just go across the triangle to get to the opposite side. And then the adjacent will be the one that's next to it. So my angle is here. There are two sides adjacent to that, this side and that side. This one's the hypotenuse, it's not a leg, so this down here is the adjacent leg. Now, some of you can look at the triangle and see it immediately, super simple. Some of you may have trouble with this. This is critical, this is super important for being able to do trigonometry, right triangle trigonometry. So study this. We'll have a few practice problems in here. We'll have a few practice problems in the video later. We'll have a few practice problems on the worksheet just labeling things, because if you set this up correctly and you remember a little trick to setting up a problem, you just go through some algebra, answers there. But if you mess this labeling up, then you're probably going to mess up the problem. Okay, so now why do we care? Well, here's what we have. Remember, back in this, we said, okay, this angle is basically going to tell me how wide this x will be. So the wider this angle, the wider the x will be. The skinnier this angle, the skinnier this x will be. So there has to be, and there is, some connection between this angle and this side. And trigonometry is how we connect those things. So trigonometry connects angles and sides. I'm going to say in triangles. However, for our purposes in this lesson and most purposes in sort of a second year high school, we're only going to look at right triangles for now. You can use trigonometry in non-right triangles, but it is not as simple. So I'll put in here, we are only going to be looking at, so only right triangles in this video. We're not going to look at law of sines, law of cosines, or anything else that these actually do give me. Okay, so here's where it all comes together. The sine, I'll abbreviate as sin. It's not sin, it's sine. And these are all based on that triangle we were dealing with before. So if I have a right triangle, I have a given angle here. I know this is the hypotenuse. I know this is the opposite leg. I know this is the adjacent leg. The sine of the angle will equal the opposite leg over the hypotenuse. It will give me a way to relate these two things. The cosine of the angle will equal the adjacent leg over the hypotenuse. So this over that. And the tangent, which I'll abbreviate TAN, will be the opposite leg over the adjacent leg. Now, there's a little mnemonic device, a way for you to try to ingrain this in your head. Because right now, this might look like a lot of gibberish. You might say, how the heck am I supposed to memorize this? So you will see and hear, and I'll repeat this a lot here. Most high schools you go to, if you walk past a math classroom and they're learning this stuff, you will hear the three words, not really words, so, ka, toa. And for right triangle trigonometry, for just starting off, I cannot stress to you how important it is that you memorize this down. So, ka, toa. So, ka, toa. So, ka, toa. I recommend write it down. Say it a bunch of times. Come back to it in an hour. Say it again. Come back to it tomorrow. Say it again. Write it down again. Make sure you have this down. Because if you can remember so, ka, toa, you can remember this. For so, ka, toa, S stands for sine, O stands for opposite leg, H stands for hypotenuse, and that pretty much tells me the sine is the opposite over the hypotenuse. And C stands for cosine, A stands for adjacent leg, H stands for hypotenuse, and finally, toa, T stands for tangent, O stands for opposite leg, A stands for adjacent leg. So if I can remember so, ka, toa, then I know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, let's look at a couple of practice problems on what I'm going to ask you to do today. We are not going to solve this full problem out. If you are wondering, and we'll go back to this again tomorrow, this would be a sine ratio because I have the opposite and the hypotenuse. But we'll get back to this in the next video. Okay, so here's my first example. In this one, I want to label the sides of the right triangle below as opposite leg, adjacent leg, and hypotenuse. Now, be careful here. I can't stress this. It's not a hard thing to do, but there's so many ways I've seen it messed up. So a lot of kids don't pay attention to this, and they just try to figure out, okay, hypotenuse is left, opposite is right, adjacent is bottom. That's not the case. It's all based on where the angles are. So in here, to find the hypotenuse, that's the one I will always do first. So first, I will go to my right angle, go across my right angle, there's the hypotenuse. The next one I always find is the opposite leg. To get the opposite leg, I go to my acute angle and go across from there. And there's my opposite leg. Again, if you're having trouble figuring out which one that is, you can always go through and do that little trick where I will cover up my angle, and the side that's left whole over here is the opposite, so you can actually move your hand over and cover it. All right. Now, The only one that's left over is the adjacent leg. So that's the one that gives people the most trouble, so I leave it for the end. But adjacent also means the leg that is next to my angle. And again, there are two sides next to my angle, this side and this side, the one that sort of makes the V. But this side here is already the hypotenuse, so the adjacent side is right here. Okay. A little different. I want to write the trig ratios for A in the diagram below. So my angle I'm dealing with is this angle here. Now, the first thing I'm always going to do is label my sides. So across from C, that is the hypotenuse, because there's the right angle. Across from this angle, there's my opposite. And the one that is next is the leg that's next to this. This is adjacent, the adjacent leg. And if I remember, so let me try to do the color coding here. We had our little mnemonic device. We had so, we had ka, and we had toa. Now, before I go much further, there are more trig ratios, but these are the three we're going to focus on in this class. We are not going to get into secant, cosecant, or cotangent, and we're not going to get into the inverse trig ratios till later. If that doesn't make sense to you, don't worry about it. Just keep on going with what we're seeing here. So I go through and say, okay, so that means S for sine, abbreviated SIN. The angle we're dealing with is A. It's the one it told me to do. Is equal to O for opposite, 8. H for hypotenuse, over 17. SOH. Cosine for C for cos. So C for cosine, so cosine. We're still doing this of angle A. Is adjacent A, so 15, over the hypotenuse, 17. And then TOA, T for tangent. Sorry, wrong color. There we go. T for tangent of angle A is opposite O, so 8, over adjacent A, so over 15. And right here, these are the three trig ratios we've learned. Okay, one more problem. Again, if you need to see more practice problems like this, there's a video in the description down below where I do that. All right, in here, I want to write the appropriate trig ratio, and this is much closer to what we're actually going to be doing. So, the appropriate trig ratio, the first thing I'm going to do is label my sides. So across from the right angle, this is the hypotenuse. Across from my given angle, this is the opposite leg. And next to my given angle, this is the adjacent leg. And again, notice how the location of these keeps on sort of rotating and flipping, but it's always based on the angles I'm given. I can see here, well actually let me write down the mnemonic device. So we have so, ka, toa. And let's look and see what I have. So if I look at my sides, I see that I had the hypotenuse was labeled as Z. I see that the adjacent was labeled as Y. But I notice there was no labeling. I have no information about the opposite side, so I'm not going to use the opposite side. And I just look at my thing and say, okay, which one has H and A? This has O and H. So let me write down what I'm doing, sorry. So I'm looking for H and A. This has H and O, that's not correct. This has H and A, this is the one I'm going to use. This has O and A, not correct. So I look at the sides that are marked or that I have information or that I'm looking for, and those are the sides I look for in my ratio, which would lead me to C for cosine of the angle here is X is equal to adjacent, the adjacent is Y, over the hypotenuse is Z. Okay, I hope this was all clear. Again, if you're not 100% confident, there are lots of things I've seen people mess up on. I would recommend look at the practice videos down below, and I'm sorry, in the description below, so you can see more practice problems. And you'll also see a worksheet down there.